everyone! In this video, we will solve a problem regarding the fundamentals of fluid flow. A liquid of specific gravity 1.75 flows in 6 cm horizontal pipe. The total energy at a certain point in the flow is 80 joules per Newton. The elevation of the pipe above a fixed datum is 2.6 meters. If the pressure at the specified point is 75 kilopascals, determine the velocity of flow, the discharge, and the power at the specified points in watts. And now, let's identify the given in our problem. So we have here 1.75 as the specific gravity of the liquid, and we have here 6 cm as the diameter of our pipe, and we have here 80 joules per Newton as the total energy, and we have here 2.6 meters as the elevation of our pipe above the fixed datum, and we have here 75 kilopascals as the pressure. So, in the problem, we are asked to find the velocity of the flow, the discharge, and the power at a specified point. By applying the Bernoulli's equation, we can solve the velocity of the flow. So we have v squared over 2g plus p over gamma plus z is equal to E, where v squared is the velocity of the flow, which is unknown, over 2g, where g is the gravity due to acceleration, plus p, which is the pressure, and gamma as the specific weight of our liquid, plus z, which is the elevation of the pipe above the fixed datum, is equal to E, which is the total energy. So, plugging in the given values into our equation, we will now have all over 2 multiplied by 9.81 meters per second squared as our gravity due to acceleration, plus 75 kilopascals all over the specific weight of our liquid, which is we can get by multiplying the specific weight of our water, which is 9.81 kilonewton per cubic meter, multiplied by the specific gravity 1.75 plus 2.6 meter as the elevation of our pipe above the datum, is equal to 80 joule per Newton, or the 80 Newton meter all over Newton. So, plugging this in our scientific calculator, we will now have the velocity of the flow, which is 37.85 meters per second. And now, let's proceed in finding the discharge. So, the equation in finding the discharge is Q is equal to AV, where A is the cross-sectional area of our pipe, and V is the velocity of the flow. So, the cross-sectional area of our pipe is given by pi over 4 d squared, where d is the diameter of the pipe, multiplied by the velocity of the flow. So, plugging in the given values into our equation, since the diameter is in centimeter, we must convert it in meter. So, we have now pi over 4 multiplied by 0.06 meters squared, multiplied by the velocity of the flow, which we solved a while ago, which is 37.85 meters per second. So, plugging this in the calculator, we will now have the discharge, which is equal to 0.107 meter cube per second. And now, let's proceed in finding the power. So, we have here the equation of the power, which is equal to Q times gamma times E, where Q is the discharge, gamma is the specific weight of the liquid, E is the total energy. So, plugging in the given values, we have now the 0.107 cubic meter per second multiplied by the specific weight of the liquid, which is equal to the specific weight of the water multiplied by the specific gravity. So we have now 9,810 Newton per cubic meter multiplied by 1.75 multiplied by 80 joule per Newton or 80 Newton meter per Newton. So the unit Newton here will be cancelled and also the cubic meter here will be cancelled. So plugging this in the calculator, we will now have the power which is equal to 146,953.8 Newton meter per second or the watt.